your time. Okay, so we are recording. We are on 1/7. So we can call this 1/7 part 2 or part 3. I don't know how many days it's taken us to do this. But we are on letter E on the second page, number 19 in the textbook. So let me actually scroll to the right problem in the textbook. Okay, we've got 2 more problems that are like the 4 that we did yesterday. So we did A, B, C, and D yesterday, and they were all problems that we had to rewrite an equation in terms of something else. We're doing the same idea for the next 2 problems, and then we're going to do some new problems. So if this is a lot for you, we'll switch over in a second. The first one we're doing is a 3D figure. It says a sphere is contained in a cube tangent to all 6 faces. Find the surface area of the cube as a function of the radius of the sphere. Okay, so a sphere is contained in a cube. So a cube's on the outside and the sphere is on the inside. And it says it's tangent to all 6 faces. What tangent means is that it's touching all 6 faces at one point. Tangent is kind of a calc term, so we won't really get too far into that as pre-calc students, but we do use it occasionally. So I'm going to draw a cube over here as best to my ability. And I'm going to make it as 3D as I can. Okay, so there's my cube, and I'm going to draw a sphere on the inside. So it's a 3D circle, essentially. I guess that's as good as we're going to get. Drawing in 3D is kind of tough on a 2D space. In order to show that this circle is 3D, I draw like a center point, and then I draw kind of a belt around the front, and then I draw like a dashed line around the back. And so if you were to like follow the belt around the front to the back, it kind of looks more like a 3D shape than it did before. I'm actually going to erase. Oh, that's not what I wanted. Erase some of this nonsense in the back. Okay. When it says it's tangent to all sides of the square, it means that at every point, like right in the middle of the square, it touches that surface of the square. So like the top of the sphere touches the middle point of the like top part of the box. The bottom of the square touches like the very bottom face of the box. The 2 sides touch the side where it needs to be, and then same in the front and the back, but I have a hard time showing that, so I'm not going to point those points out. But essentially the way I drew it is that I want us to think that this point is on the square, but it's also on like the sphere as well, so it hits at that one point. On the problem we did in the last class, we had to do some right triangle trig. I had to remind you what a 45, 45, 90 degree triangle was. Luckily, we don't have to even do that much work here. All we have to do is think about what it means to be like the radius and what the surface area means. So this problem says that we want to find the surface area as a function of the radius of the sphere. So we're finding the surface area of the cube. Now, I don't know about you, but I didn't remember what surface area was, so I Googled it, but we are smarter than that, and we can figure it out without having to Google it. So if I think about surface area, it's like the area of all of the sides of my cube. Well, there are how many sides of a cube? There are 6 sides in a cube. And then if I wanted to find the area of one of the sides, it's just the side times the other side. So it'd be like side squared. I use X instead of S because if I use S for side, I get confused with a 5 sometimes. So I personally use an X. So if I can find out what any of these sides are, and since it's a cube, all of the sides are the same, length, height, width, it's all the same. If I can find what one of them are, then I can solve. Now, the radius is in here. The radius is anywhere from the center of the circle to anywhere on the outside of the sphere. So I can go around the outside, around the up and the down, or I can go around like kind of the middle shape. I don't know if that helps you see like the sphere is 3D. You can go anywhere. I think the easiest way is to think about going from the top, from the middle. So if I touch the point that's the same on the cube and on the sphere, that's R. And then it's going to be the same distance from the center down to the bottom. That's also R. So if we break that apart, the distance from the top to the bottom is 2r. And that's what all of the sides are going to be. You could do that all the way around, or we could know it's a cube, so all of the sides are 2r. I could label all of these 2r all day if I want to. All of them are 2r. So that being said, I can replace my x with 2r, and my area is 6 times 2r squared. We got to square both the 2 and the r, so don't forget that. Square my r, square my 2. 2 squared is 4, and then r squared is r squared. So I've got 6 times 4r squared. Well, I can do 6 and 4. That gives me 24. So I've got 24 r squared. That is my area. Let me zoom out so you can see it all. Any questions so far? Okay, so that was my square and my sphere. We had to use a little bit of knowledge about what tangent meant, but other than that, that one was pretty simple. All right, this next one's a little bit more challenging, so everybody make sure you're buckled up, ready to go on this one. It says, an isosceles triangle has its base along the x-axis with one base vertex at the origin and its vertex in the first quadrant on the graph of y equals 6 minus x squared. Okay, great, that's a lot. So we're gonna draw a picture. Oh, zoom in, thank you. Okay, so I'm gonna draw my axis somewhere off to the side. Again, my notes are a disaster, so as long as you know what your notes are doing, that's fine. You can just write anywhere. I have this isosceles triangle where one of the vertexes is at 0, 0, and then another one is just somewhere along the x-axis. And this is my base. So from the origin to some point, we don't know what point that is, it's just some point, is my base, B. It's an isosceles triangle, so it means that my other two sides are the same length. If I could draw a straight line, that'd be cool. There we go, that's straight. These guys are the same length. I don't know where that point is, but I do know that it's on the line y equals 6 minus x squared. If we go back in our brain and remember what we just did with transformations, 6 minus x squared, well, the parent function is a parabola, it's just a quadratic. The 6 makes it move up 6 units, and that negative makes it flip. So it's flipped over my, it's flipped down. It was facing up, now it's flipped down, but it's starting up here at 6. So it's a downward facing parabola at 6, and it's gonna go through that point that's on my isosceles triangle. The reason this is helpful is because I want to know what point that is. And I can do that because I have a function. I know my B is my base, and then I don't know what my height is, but if I know what my Y value at this pink point is, that's the same thing as my H. I went over a certain amount of units and then I went up a certain amount of units. My Y is that H, and my X deals with my base. If my whole distance from this point to this point is B, I'm only doing half of that. So my X value is 1/2 my base. My directions say write the area of a triangle as a function of the length of the base. So that's all fun and games. Area we know is 1/2 base times height. That's cool. The only thing I gotta figure out is my height. So that's why I was all bent out of shape about the Y value and the height a second ago, is because in order to do area, I have to know my height. Now, if I'm using the X value of 1/2 B, well, I can find its corresponding Y by plugging it in to the function that it's on. If it's on the line of Y equals X minus 6, or sorry, 6 minus X squared, I can figure out what that Y is by plugging in 1/2 B for my X. It's not gonna be a real number, it's not gonna be nice and pretty, but I can figure out where it is based on my B. So I'm gonna do Y equals 6 minus X squared. And instead of writing X, I'm gonna write 1/2 B. I'm going to do some algebra to solve. So that's going to be a phrase I say a lot today. I'm going to do algebra. I'm going to do algebra. That just means I'm simplifying, I'm distributing, I'm squaring, I'm adding, I'm combining like terms, whatever I need to do. So if I distribute that in, I get y equals 6 minus, well, 1/2 squared is 1/4, and then b squared is b squared. Since the 1/4 is being multiplied by that b squared, I technically can't do anything. I do want to do one thing though. The one thing I want to do is make them all one fraction so I don't have to play with two different fractions. If I wanted to make this one fraction, I would have to do, I'd have to make 6 a fraction with 4 in the denominator, which would be 24 over 4. So I could just rewrite this as 24 minus 1b squared over 4. These are the same thing. These are the same things. The second one is just a fraction, which is going to make my life easier in a second. This was my y. So I'm going to go put that on my equation, or my coordinate point, 24 minus b squared over 4. And remember, the whole reason we did y was to find out what my h was. H was the only thing that had to be changed or had to be dealt with in order to do my area. So now I'm ready to plug in to do my area. That 24 minus b squared over 4 is my h. Everything else is the same. My area, my 1/2, my base is all normal. But instead of writing h, I'm going to write 24 minus b squared over 4. The last thing I have to do is just simplify. My denominators get to go together, so 4 times 2 is 8. And then I can distribute that b inside. So 24b minus b to the third. All right, all of these problems, A through F, we're just rewriting in terms of something else. I can zoom back in, my fault. Some of them I think were easier than others. This one I think was one of the more challenging ones. I'm not asking you to do it by yourself, but does anyone have any questions as you followed along with me? Okay. All right, I'm gonna move right along. So we've got 3 more on this page. So I need to move my textbook page to get to 28. So I'm gonna do that. Make sure you have this one all the way copied down. All right. This next one, we are going to use our calculator for. It's a pretty simple one. The hardest thing is the calculator window, which I struggled with live time last class, so I hope I can do it better this class with you guys. And then 31 and 32, I think are pretty simple, and they're like super important questions that will be on tests, will be on your final. We need to know those too in a second. Well, let's look at 28 first. It says, Ruth is weighing 2 job offers from the sales department of 2 competing companies. One offers a base salary of $25,000 plus 5% of gross sales, and the other offers a base salary of $20,000 plus 7% of gross sales. What would Ruth's gross sales total need to be in order to make the second job offer more attractive than the first? Okay, let's write these as equations. So the first job, no matter how much she sells, and this is a super applicable problem. I have a lot of friends my age who are working in sales, and so they may make like a low base salary, but depending on what they sell, they can make way, way, way more. So this is important for her to know which job is the best job so that she can make the most money for the same amount of sales. So the first job, she's making $25,000 no matter what. But then depending on how much she sells, she makes 5% of that. I'm going to use the variable G. You can use X, you can use S, you can use M. I don't care what you use. I just use G for gross sales. The second job, she makes a base of $20,000, but this time she makes 7% of her gross sales, or 0.07. If she sold nothing, the first offer would be the best offer. But as she sells more, there becomes a certain point where the second job is better for her. So what we want to find is how much, what does G equal in order for the second job to be the better option. You could even solve this algebraically. So like you could technically take like these pieces. Oh, I'm going to get that G anyway. Okay. Whoa, that's not what I wanted. Whatever. I'll write G over here. You could take the second expression and write it next to the first one. If I want the second job to be the better offer, then I would need to do the second job is greater than the first job, or the first job is less than the second job if you want to solve it algebraically. What I'm going to do is I'm going to plug these into the calculator. This job 1 will be my Y1, and then the job 2 will be my Y2, and then we're going to graph them. There's going to be a point where they intersect, and we'll see one goes higher. The second job will go higher than the first one. So let me get my calculator. Here it is. Okay. And I actually have a couple things graphed, and I have it in my Y3 and my Y4 just because I don't want to rewrite this. Typing sometimes takes me a while, so I don't want to retype it. You can ignore my Y1 and my Y2 because you'll do those in a second. I'm just not going to retype. So I guess technically I wrote her jobs in Y3 and Y4. Okay, half the battle is the window. Typing it wasn't hard, and honestly, writing the equations I don't think was hard. I think you guys could have all done it by yourself. Now is where the window comes into play, okay? And I had to mess around with this a lot last period, so let's see if we can kind of guess a little bit better. Okay, if she's making 25,000 and then more than that, and 20,000 and more than that, her Y is going to be kind of high. So let's make that Y like, I don't know, like, let's make it 100,000 and see what happens. 100,000. My Y, or my X min and my X max, I don't really know what to guess for her sales. I know it's going to be more than like 10, but I don't know how high it's going to be. So let's put it at like, I don't know, 500 and see what happens. So my X min is at 0, my X max is at 500, and then my Y min is at 0, and then my Y max is 100,000. That might be too high, it might be too low. We're going to find out. So we go to our graph, and as you can see, I've got 2 lines, and honestly, it doesn't look like they're doing a lot. That means that they intersect somewhere like way over here, so I got to really up my X. Now my Y value might even be okay to be a little bit lower, because look how much dead space I have up here. I'm not going to change my Y's yet, but if I get closer to an intersection, I may zoom in on the Y's, but I don't want to change my Y's yet. We got to make my X's bigger. So let me go to my X's. Let's make this like, I don't know. Let's just add a 0, make it 5,000 and see what happens. Okay, I need to minimize that. That's so annoying. Okay. 5,000 and see what happens. Okay, we're still not there yet. That means it's got to be even bigger. Let's make it 50,000. You may be getting to the point where you're like, I'm so annoyed, nothing's happened yet. But do you see how they're becoming more defined lines that are sloping up a little bit each time? We got to go one more. I don't know if 500,000 will be too much or not, but I'd rather go too big than not enough. So I'm now at 500,000, 500,000. Aha, there we go. What happens sometimes on tests and quizzes is you guys get like the first one where it's just 2 lines that never intersect and you're like, I messed up. And my only hint can be like, you got to play with your window. Sometimes it takes you a minute. Sometimes it takes you like 5 or 10. It took me like 5 minutes last period to get this right. So I had a better idea going into this with you. But when in doubt, you got to change your X's and your Y's and kind of play around. Because if you get to a test and you're like, I know they should intersect and they're not yet, the Y either needs to be bigger or the X needs to be bigger. So on those, I can't really help you than just say like your window is wrong and you need to make it bigger until you see it. So I finally found my intersection. So now we're going to do our second trace and find where they cross. Where they cross is how much she would need to sell for both of the deals to be the same. And then we just want greater than that to make the second deal better. Let me zoom out. Okay, first curve. Okay, second curve. Guess. Perfect. They intersect at $250,000. I'm gonna just play around so you can also see my window. If you solve this algebraically, you probably already solved it before we did graphically, but I wanted to show you graphically, and I wanted to show me struggling through it so that you knew that it's okay if you do too. We just found that we found that where they're the same is where G is $250,000. So in order for the second deal to be better, she needs to sell more than $250,000 worth of sales. That's a lot of money of sales. I don't know what she's selling, but that might be a lot. So she needs to think if she's going to take either job, if she can sell more than 250,000, the second job's a better option. But if she can't do that, then the first job's a better option. All right, I don't have a lot of work here because we just put it in the calculator and kind of played around until we found the intersection. Anybody have any questions? All right, the next one uses the calculator, but not the same way. So I'm going to pull the problems back up. And we're going to do 31 and 32. These are what we call mixture problems. These are called mixture problems. So I'm going to write that next to this. And these are for sure on the next test we take. They're probably on the final. They're not hard, but we need to respect the process in order to know how to do it. Okay, so my problem says how much 10% solution and how much 45% solution must be mixed together to make 10 gallons of 25% solution. Okay, oh no, 100 gallons, sorry, not 10, 100 gallons. So I'm essentially taking a cup of a 10% solution and a cup of a 45% solution and mixing them together. And together they're gonna make 25% of this solution and it's going to make 100 gallons of it. So I need to know how much of each one I'm gonna pour in. Now it gave us a picture. So we're gonna use that picture. And honestly, if it doesn't give us a picture, we're gonna draw one like this every single time. What it has is like 3 cups. Solution 1 is made up of 10% solution, and we don't know how much is in it, so we say it's X gallons of 10% solution. There's no reason that 10's on the bottom. If you can write it all in one line, great. I just don't have room for that. We're adding that to a certain amount of gallons of the 45% solution. Now, what a lot of us would be tempted to do is write, oh, well, we'll just use Y because we don't know how much is there. We cannot use Y because I only have one equation. I can't solve one equation with 2 variables. So I can write this in terms of X. I can write 100 minus X gallons. And that's what they have on the little blue trash can symbol for us. Together, they're going to make 100. So if one of them is X, the other one is just 100 minus X. Are we okay with that? And then the last thing, together they equal a combined solution that's 100 gallons of 25% solution. The reason we draw these pictures is because now I'm easily able to make a little equation from this. If you remember back from Algebra 1, anytime you use of, it means that we're multiplying. So I'm doing 100 gallons of 10%. So I'm going to do X times 10% or 0.10 as a decimal. Same idea with the next one. I'm doing 100 minus X gallons of 45%. So I'm going to do 100 minus X times 0.45. And then last I'm doing 100 gallons of 25%, so I'm doing 100 times 0.25%, or sorry, 0.25, yeah. Now it's just algebra and we just solve. So I'm gonna multiply as I can multiply, I'm gonna combine like terms when I can, I'm gonna divide when I'm done. So I've got x times 0.1, which is 0.1x. I'm going to distribute this 0.45 to the x and to the 100. Oh, that's an easy thing to multiply by. So 100 times 0.45 is 45, and then minus 0.45x. And then 100 times 0.25 is just 25. We're going to minus our 45 from both sides. I'm going to combine my 0.1 and my negative 0.45. So I get negative 0.35 equals negative 20. We might be like, ooh, yikes, why do we have two negatives? Well, don't worry. When we divide by a negative, then I get a positive. I added those two together. I moved my 45 to the other side, and now I'm going to get x equals, and this is not a nice, pretty number. This, I get 57.1 gallons. Now, you could have used x in either place. You could have used it for 10%, or you could have used it for 45. I don't care what you do, just make sure you label appropriately. Since we use x for the 10%, then I know that I'm using 57.1 gallons of my 10% solution. If I want to figure out how much of the 45% I'm doing, I'm going to do 100 minus x. Well, 100 minus x is going to be 42.9. And that's gallons of my 45%. And this is all I want as my answer. So what helped us is we drew a picture and then we just used algebra to solve. So number 32 is a very, very similar problem. If you're not quite sure about 31, I'd hang on and listen to 32 and then we can see what questions we have because it's very, very similar. This one doesn't give us a picture, so I'm going to draw my own. It says the chemistry lab at University of Hardwoods keeps two acid solutions on hand. One is 20% acid, one is 35% acid. Okay, that's just nonsense I don't need to know. The real question says how much 20% acid solution and how much 35% acid solution must be used to prepare 25 liters of 26% acid solution. So we're going to do exactly what we did. We're going to draw little boxes. We're going to fill them in. So I've got one box right here plus another box right here equals my third box. If you struggle with what to do, I would pick one of them to do first. Since I have all my percentages, I'm going to do that first. I know that the total percentage is going to be 26%. And so the two other ones are what's spread out with my other two, I guess, buckets. One is 20% and one is 35%. One is 20%, one is 35%. Now I know my total number of liters is going to be 25, so that goes on the total, 25 liters of 26%. I don't know how much is in the other two, but I'm going to use x for one, and I'm going to use 25 minus x for the other one. I just generally like to do x on the first one. There's no reason, that's what I like. And then I'm going to do 25 minus x on the second one. Now that I have this, I'm really ready to just set up an equation and solve. X of 20% is x times 0.2. 25 minus x of 35% is 25 minus x times 0.35. And then the last one is 25 of 26. I'm going to do 25 times 0.26. Anybody have any questions so far? Okay. Now I'm going to multiply, do my algebra, 0.2x plus, these don't work out as nicely, but I get 8.75 minus 0.35x. And then 25 times 0.26 is 6.5. I'm going to combine my like terms, 0.2 minus 0.2 minus 0.35 is negative 0.15x. And then I minus my 8.75 to both sides, and I get negative 2.25. Divide by negative 0.15, and I get x equals, oh, this is a nice number, 15. It's a nice, pretty number. So then I've got answers. My answers are going to be a certain amount of liters for my 20% and a certain amount of liters for my 35%. Since I did x of 20%, my x goes with that. So I'm going to do 15 liters of my 20% solution. And then I have to do 25 minus x, or 25 minus 15 for the 35%. Well, that's going to be 10 liters of my 35%. What questions do we have? None? All right. We're going to turn the page over, and we're actually going to skip number 35 because I just don't want to do it. But I will try and do the other three. So we're going to skip 35. I just don't feel like doing it. Now, I think the next one we're about to do is the hardest one. I'm not asking for you to know how to do this on your own, but I'm just asking that you can follow along with me. So if you're confused, let me know. But I just want to make sure on 37, letter K, that we're just following along. You understand how I got where I got. Okay. So let me scroll down to 37. Sorry. 37, it says water is stored in a conical tank with a faucet at the bottom. Okay, first thing I'm going to do is draw a conical tank. If it's conic, that means it's cone. And so I'm just essentially drawing a big ice cream cone. You want to connect? There we go. I'm not great at drawing, so I need all the help Notability can give me. Something's not right. Okay, we'll pretend that's nice. So it's a conic tank. It says it has a depth of 24 inches and a radius of 9. So that means the top of the cone has a radius of 9 inches. So anywhere from the center to any point on the outside, it's 9 inches. And then its depth, or if you'd rather think of it as height, is 24. So from the very top of the cone to the very bottom of the cone is 24. And it says it's filled to the brim. Okay, that's important. So it's so full of water, it's at full volume. Its total volume is here now. If the faucet is opened to allow water to flow at a rate of 5 cubic inches per second, what will the depth of the water be at 2 minutes? Okay, first thing we have to do is we know that it's filled to the brim, so it's all full of water. Let's find out what the total volume of this is, and then we'll see how much we lost as we open our faucet. So my first thing I'm going to do is find total volume. Now, if you don't remember what volume is for a conic shape, I'm going to just give you a little reminder. V equals 1/3 pi r squared h. Okay, that's not bad. I have r and I have h, and I can find volume very easily. So since I'm doing the entire shape, I'm going to use those values and plug in. So I've got V equals 1/3 pi. For R, I'm going to use 9. And for H, I'm going to use 24. All right, that just models my picture. Now I'm just going to solve. All right, I've got V equals 1/3 pi times 81 times 24. If we simplify that, I've got 3 and 24 have a common factor, so I'm just doing 81 times 8. I'm going to leave pi in here, but I'll do a decimal in a second. If I leave pi in here, I got 648 pi inches cubed. We know volume is in cubes. We know volume is in cubes. So my total volume, if that whole tank is full, I'm at 648 pi inches cubed. I don't know where my height will be after 2 minutes of this water being of the faucet being open, but essentially I know it's not going to be at the same place. So it's going to be like maybe down here somewhere. We're going to find that out. In order to find that out, let's first figure out what the volume of what's left will be. So if I know that I'm losing 5 cubic inches of water per second, I can find out what my new volume is going to be using that rate. So to find the remaining water, so after I open the faucet and then I close it after 2 minutes, to find out what's remaining, I can do my total volume minus what's lost or what's drained out or what's flowed out, whatever word you want to use. I already know my total volume. I just found that. That's my 648 pi. And I actually also know what's lost. It says at a rate of 5 cubic inches per second, I'm losing it. Well, 648 pi is also in cubic inches. So I'm going to do 5 times, it says 5 inches per second. If I'm going for 2 minutes, oh, I can know how many seconds that is. In 2 minutes, there's 120 seconds, right? So I can do 5 times 120 and minus that off of my total volume, and that will tell me what the remaining volume is going to be. Remaining volume. And so I'm going to hope that you trust me to throw that in the calculator. I did 5 times 120, and then I did that number minus my total volume, and I got out 143 5.75. Is that right?
That's what I got.
Is that what you got? Okay, I was afraid my decimal was off. Okay, that seems like a really big number, but think about it. If I had 648 times pi, that's going to be a really big number. That's almost 20,000. And then I minus off 5 times 100 something. So that's like 500. That seems to make sense on where I'm at. So this is my remaining volume in inches cubed. I don't want to know what my volume is. It says I want to know what the depth of the water will be. So I want to know essentially what my new H is going to be. This is where I think it gets the most confusing. I have my H and my radius, but as I go down this conic shape, my radius changes. So if I am here now, my radius is no longer 9, it's something less than 9. And my height is no longer 29, it's less than 29. However, since it's this shape, it's going to stay in like relation with each other the whole way. So I can think of it as a ratio. I can think of whatever the radius is in relation to the height is going to be the same no matter where I'm at. So that's the same as 9 over 24. That's what my original piece was, and that's going to help me find my new height and my new radius. Now, I don't know what either of those are, but I know that I want to know what the depth of the water is. So I want my final answer to be in height. So if I can isolate R, then I'll have an expression in terms of height that I can solve for. So if I multiply by H on both sides, I get R equals 9 over 24H, and I can plug that in to my volume formula to find H. The reason I'm going to plug it back into volume is because I just found remaining volume. I have a volume. I know my new volume is this 1,435.75. And I know that my 1/3 is going to be the same. I know my pi is going to be the same. And I'm going to do r squared times h. And I want to find h. Since I can only solve if there's one variable, that's why I put r in terms of h. So I'm going to replace r with 9/24h and then squared. And now what I'm going to do is I'm going to do algebra in order to solve. So I'm going to square what I can, divide what I can, combine what I can, root when I can. All right, the left side hasn't changed yet, but I am going to square everything in here. So I squared the h, I squared the 9, I squared the 24. So I get 81/576h squared times h. I'm allowed to multiply the numbers that I have together. So I'm going to multiply those two together. And then I'm going to multiply my h's together because those are all the same. Still haven't done anything with the left side. But now I've got 81 over, what was this? It's like 720 or something like that. I don't think my calculator kept it. Nope. 576 times 3 is, oh yeah, 1728 pi h cubed. I'm going to jump over to my calculator to simplify like this last bit. I'm going to divide by pi and then multiply by the reciprocal. You can also make 81/1728 a big fraction. That's fine with me. And then we're going to cube root. Now, sometimes we forget how to cube root, so that's why I'm doing this in the calculator. So I have, let me just clear this all out. It looks messy. So I've got 1435.75. And I'm going to divide that by pi. You can divide it by 3.14. I just divided it by actual pi. Then I'm going to multiply it by 1728. I'm just multiplying by the reciprocal, and then I'll divide by 81. You could have made that big thing a decimal and then just divided by it. So now I get this number, and this number is equal to h to the third. So I'm going to cube root. Cube root is if you go to math and then go down to number 4. So cube root, and then if I want to not copy this down, if I want this to appear over there, I can write second answer, and then it just pops right in. And I press enter, and I get h is 21.4 inches. Whew, so we just did a ton of work to find out that the new height of my tank, the water is now at 21.4 inches after I drained water for 2 minutes. So this is what I have for my answer. Again, I do think that's the hardest one we've done, so I hope that you could follow with me. I'm not necessarily expecting you to do that on your own, but I just wanted to make sure you could follow along with me. I want to get to the next 2 problems. Are there any questions before I move on? All right, the next one is going to be a calculator one, so get that out. Let me pull up the problem. Okay, this one says number 38. Reggie invests $12,000, part at 7% annual interest and part at 8.5 annual interest. How much is invested at each rate if Reggie's total annual interest is $900? All right, this is super similar to what we just did with our little boxes of solution. This is not an equation. I'm just kind of drawing like a thought process, thought diagram, whatever. If he has $12,000, he has 2 options. He can either invest it at 7% or he can invest it at 8.5%. I don't care which one you choose, but one of them is going to be X amount of his money. Again, we can't use Y because if I used Y, then I'd have to need 2 equations and I don't want to do that. But I can do this next one is 12,000 minus X. So whatever he invested at the 7%, I'll minus that from 12,000 to get what he's investing at the 8.5%. I can make these an equation, so I can do 0.07 X plus 0.085 times 12,000 minus X. And it says we want his total annual interest to be $900. So together, that should equal $900. I'm going to graph this again, and I'm going to see where these intersect. So I'm going to graph this guy at my Y1 and this one at my Y2. And actually, this is what I had plugged into my calculator before that I just turned off. So I'm going to go turn those on now. If I light up their little equal sign, then they will graph. I'm going to turn off the other ones. Again, I'm at my Y1 and my Y2. So on my graph, I'm looking for the blue and the red line. All right, we got to figure out my window. If my horizontal line is at 900, I at least need to be at 900. We might want to be even a little bit above that. So let's make my Y's, I don't know, let's make it, 1,000, 2,000 maybe. Oh, that's too many zeros, 2,000. I have to at least see 900, so I think 2,000 will be enough. It might be too high, I don't know. Now my Y min, or my X min and my X max, I actually do know this one because he only has $12,000. He can't do more than 12,000, but that means that he could invest $0 of his 12,000 somewhere, or he could invest all 12,000. So I want my X max to be 12,000. My X min and my Y min are 0 just because I can't have negative values. And let's graph. Oh, nice. I can see a nice, pretty intersection. Let's find it. Oh, no, go back. So second trace, intersect, first curve, second curve, guess. All right, it says 8,000. That means that the X value is 8,000. And so in terms of our graph, of our picture, 8,000 is how much he invested at 7%. So I'm going to say he invested 8,000 at 7%. And then we'll say he invested the rest. So 12,000 minus 8,000 is 4,000. He invested that at his 8.5%. And that's my answer. Any questions? All right, I am going to do this last one. It's not a calculator problem, but it is conversions like in chemistry. So I hope we remember some conversions. It says the tire of a moving bicycle has radius of 16 inches. If it is making 2 rotations per second, find its speed in miles per hour. Okay, so I've got a bicycle, got a wheel. Its radius is 16 inches. In one rotation, we're doing the circumference. So one rotation is equal to my circumference. Well, we're good at circumference. Circumference of this would be 2 pi r, or 2 pi 16, which is 32 pi. That's one rotation, but he's making 2 rotations per 1 second. So he's not just doing 32 pi per 1 second, he's doing 64 pi per 1 second. Because that's 2 rotations. I did 2 times 32. And that's in inches. And let's actually figure out what 64 pi is in terms of actual inches. I got 201 inches. I'm actually going to start a whole new line. 201 inches for 1 second. Depending on how you did chemistry conversions, I had a chemistry teacher that had us do kind of like a big railroad track like that. I know some of yours have just taught you to just multiply it. So we want to go from inches and seconds into miles per hour. So my final answer should be miles on top and hours on the bottom. Your best way of doing it is to just isolate one. So I'm going to do seconds to hours first because I think that's easiest. So seconds, okay, I need to get to hours, so I got to go minutes first. So there's 60 seconds in 1 minute, and then there's 60 minutes in 1 hour. Okay, my seconds units crossed out, my minutes crossed out. Okay, I've got hour at the bottom. That's good. Now I need my inches to go to miles. Okay, well, we got to go to feet, and then we can go to miles. So inches, there's 12 inches in 1 foot. I had to put the inches on the bottom so that my units could cancel out. And then I've just got one more. Now I've got feet to miles. I think it's 5,280 feet per 1 mile. I think I did that right. Now my feet cancel out and I've got miles on top, which is great. So all I'm gonna do is just throw this in my calculator. I'm gonna do 201 times 60 times 60, and then divided by 12, and then divided by 5,280. That gives me, move this over. And if you don't trust me, throw it in your calculator, and I trust for you to check me, but since it's the very end, I'm just gonna tell you what it is. I get 11.4 miles per hour. So we took the circumference and then did all my conversions from inches to miles and seconds to hours to get my final answer. Okay, we finished 1-7. I know that it's a minute over. Does anyone have any questions before I stop sharing my screen? Okay, I'm gonna stop sharing. You have to have 1-7 done by next Tuesday. So you can do it Monday after, even if you want. On Mission Monday, we'll get into Unit 2 notes, and that's on Schoology as a PDF. And if you need anything, let me know. Have a good, safe fall break. Thanks for doing a whole pre-cal class at the end. I know that we're tired and done. Have a great fall break.
Thank you.
Thank you.
Bye, guys.
Thank you.
Thank you.